Today's objective is to use permutations and combinations. Flashcards. Say the answer when you know it. 6. 120. 24. 720. 12. 1440. 12. 360. 5. 30. Example 1. We have the old license plate system, which is 1, 2, 3 letters, and then you would have 3 numbers at the end, separated by a dash. That is the old system. So I would have to have nothing but letters here, and nothing but numbers here, excluding personalized plates and stuff like that. Let's say that you must have letters here and you must have numbers there. No other options. How many different license plates are possible under those circumstances? How many choices do you have for this spot here? 26. And this spot. And this spot. 26. So in other words, it's 26 to the third power. And how many choices do you have here? 10, because 0 is a number. 10, 10, and 10. So you would have 10 to the third power. So in other words, we would do 26 to the third power and come up with 17,576 and multiply that by 10 3 times, or 10 to the third, and have this for the final answer. 1757600, and that's 17,576,000 different possibilities for license plates. In example number 2, we now have another license plate system we're going to look at. 1, 2, 3, 4, and then 1, 2, 3. So we have a grand total of 1, 2, 3, 4, 5, 6, 7 different spots. However, you can have any character you want there. That's anything. For this, it must be a letter. This must be a number greater than 5. This must be a number less than 4. This can be anything. This is a number less than 3. And this is a number greater than 6. So with all of those characteristics, you have to figure out how many different license plates could be made using those parameters. If I have any option available to me in the first spot, how many choices are there? 36. And if the next one has to be a letter, how many? And if it's a number greater than 5, how many choices? We have 6, 7, 8, and 9. So that would be 4. And then if it's less than 4, if it's less than 4, we have 3, 2, 1, and 0. So that would be 4. If it's anything, you can have 36. If it's a number less than 3, it's how many? 3 of them. And if it's a number greater than 6, 3. So now you have to multiply all of those together, and you can shorten it up a little bit. That's 9, and that's 16. 16 times 9 is 144, and then you could multiply by 36, and then by 36, and then by 26, and come up with the following: 4, 8, 5, 2, 2, 2, 4. 4,852,224 different options. Practice number 1. This license plate system has a total of 6 different places. For this one, it could be A through E. For this one, it could be M through W. And this one can be anything. For this one, it's going to be a number. This one must be even, and this one must be odd. How many different license plates can be made? The solution for this practice problem: A through E is how many letters? 5. And what about M through W? 11. Anything. And for a number, even, 0 is an even number, so it's 0, 2, 4, 6, 8. So it is even, it's 5. Oh, it goes there. And then odd, how many odd numbers? 5. Alright, so you can have 25 and 10 is 250. 250 times 55. And then throw in a times 36 and come up with 495,000. 495,000. On this problem, this license plate can only have 5 characters. This one must be an odd number, or A through E. This one is an even number, or Q through T. This one can be anything. This one is a number greater than 3. This is a number less than 7. Also, what's possible on these license plates is to have a dash as a character. You can have a dash as a character. On this problem, it could be odd or it could be A through E. How many odd are there? And how many A through E? 10 total possibilities there. You have 5 even, and how many letters are from Q to T? Q, R, S, T. 4. So you have 9 possibilities. Any. This is what I wanted you to think about and not phone a friend or text them across the room or whisper it. Anything. It could be anything. So it could be any number, it could be any letter, or it could be the dash. So you have 37 for this one. And then for greater than 3, how many numbers are greater than 3? How many numbers are greater than 3? 6. How many are less than 7? 7. Now you can do 42 times 90. 42 times 90, and then multiply by 37. You should have come up with 139,860, which is 139,860 different possibilities. Example number 3. Yesterday you had the permutation formula and you had two different variations. One is just the factorial when it's a line of things, and the other one is when you have the books or the people that were in a group and they're having their picture taken, and how many ways you can line up so many people from that group. This one is about a pizza shop, and it makes, obviously, pizzas, and it has 12 different toppings to choose from. It has 12 different toppings to choose from. What this place wants to figure out is how many different possibilities it could have for menu items, as in a pizza with certain items on it. Let's say it only wants to sell 3-item pizzas. How many 3-item pizzas can I get if the place has 12 toppings to choose from? And we're not going to count double crust and double pepperoni and all that stuff. It's just straight, flat out 1 item, 2 item, 3 item. How many 3-item pizzas can be made? You have to know the combination formula. This is a combination. And the combination formula is NCR. And on the top, you're going to have n factorial. On the bottom, it's r factorial times the quantity factorial of n minus r. The total number of items they have to choose from will be 12. And then how many you're going to take away to make the pizza will be 3. That is r. And then you have to do n minus r, which is 9. So that's 9 factorial. You can simplify this in a number of ways. But if you think about it, 9 factorial taken out of 12 factorial leaves you with 12, 11, and 10. And then on the bottom you still have 3 factorial, which is 6. 6 can come out of 12 twice. So you have 2 times 11 is 20, 22 that is, and times 10. 22 times 10 is 220. Example number 4. A pizza shop offers a total of 15 toppings. How many different 5-topping pizzas can be made if you have 15 toppings to choose from? In combinations, it doesn't matter what order they show up. With permutations, remember we had the photographer, and they have to line them up a certain way. Photographers like people large to small, small to large, or the biggest one in the middle, then they fan out. But this one, it makes no difference, and that's why we use combinations for this pizza topping problem, because if I put pepperoni on it, and then I put anchovies, and then I put sausage, it's not going to matter if I put the sausage first, then the pepperoni, and then the anchovies. It's not going to matter. Now, some people are really picky, but we're not picky in this problem. So, to find the answer, you start with 15, and you're going to choose 5. So it is 15 factorial over 5 factorial times the quantity factorial of 15 minus 5. All of this comes down to being 15 factorial over 5 factorial times 10 factorial. Now notice that you can cancel out. The 10 factorial will eliminate everything of 10 on back in the top. So we have 15 times 14, 13, 12, and 11 on the top. And on the bottom you have 5 factorial. Well, now 5 factorial is 5 times 4 times 3 times 2 times 1. You can cancel out a 5 with the 15 to get a 3 there. You can cancel out a 4 and a 3 and the entire 12 on top. So these are wiped out. And then you still have a 2 you can mess with and make this one into a 7. So you end up with 21. 21 times 13 times 11, and there's nothing left on the bottom. What did you get?
3,003.
Yes, 3003. The solution for this practice problem is 13 factorial over 6 factorial times the quantity factorial of 13 minus 6, which comes down to being 13 factorial over 6 factorial times 7 factorial. You can eliminate everything from 7 on back and have 13, 12, 11, 10, 9, 8, and 7. Well, actually 7's not in there. And then still have 6 factorial on the bottom. So for 6 factorial, that's 6 times 5 times 4 times 3 times 2, and we'll leave the 1 out. 6 and 2 is 12. Those are gone. You have a 5 on the bottom and a 10 on the top. That becomes 2. 3 and 9 is 3. And that's pretty much it. The 4 will have to stay on the bottom. Well, no, actually the 4 and the 8, since I put it on a second line. So you'll have 13 times 2 is 26. And then we'll multiply 26 by 11. And then by 2 and by 3. And there's nothing left on the bottom. So you should come up with 1716, but don't come up here yet. The other one is that I gave you calculators at the beginning of the school year. We spent a lot of time doing programs and going through all kinds of stuff. You must learn to investigate your calculator because it can save you plenty of time. Waddell is saying yes. Yes. He's giving me an amen. On your calculator, if you do this, type in, for this problem, type in 13. And then hit math. And right arrow over to probability. And you will see NCR on your screen. Choose NCR. And then type 6. And then hit enter. What number comes back? 1716, yes. Your calculator is your friend. You must learn to pay attention to it. For practice number 4, you must combine a lot of the stuff that we've done so far and see if you can arrive at an answer for this. The answer on this problem is 30.